Hi everyone, we are continuing with alternating series. Today we're going to talk about remainder or error. Right, now the cool thing is that our error is always going to be equal to the next term. Okay, well I should say like max error. And our maximum error is always going to be equal to the next term. Okay, what I mean by that is if I have a series and I evaluate the first, say I went from 1 to 4 instead of 1 to infinity, then my maximum error would be the fifth term. Okay, so it's always going to be the next term. Right, and that makes it super simple. Right, so first, they want us to approximate the sum of this series just by using the first four terms. Now, the big S always stands for sum. So using the first four terms, so essentially they want me to find S sub 4, which is cool. We're just going to plug in 1 through 4. Right, so if I plug in 1, I get 1, then I get negative a half, I get positive 6 minus 1 over 24, which is 5/8 or 0.625. Okay, so this is my approximation just by using the first four terms. Now I know this isn't the actual value of the series because it goes on to infinity, but it's an approximation. Okay, so I found the first four terms. That means that my fifth term, okay, so the difference between S and A, if you don't know, is S is a sum, so you're adding them together. A is just the term, so it's just one of your numbers, like in a sequence. Okay, so I use the first four terms to find my approximation. That means the fifth term is going to be my maximum error. Now my fifth term, if I plug 5 into here, is 1 over 120. Okay, this is my maximum error. This is less than 1/100th. Okay, so this is why my error is going to be less than 1/100th. Okay, or it differs from the actual value by less than 1/100th because my error is the next term, which is 1 over 120. Right, and that's really all you have to say. Okay, so for part C, they want me to use this to explain why my sum can never equal 0.7. Okay, well, my approximation, right, so S sub 4 equals 0.625. Okay, now if my maximum error is 1 over 120. So if I add that to get an upper bound, I get 0.633. Okay, if I subtract that to get a lower bound, I get 0.616. So I know that my sum has to be somewhere between 0.616 and 0.633. Okay, my actual sum. Right, so the actual value of this series has to be somewhere between 0.616 and 0.633. And naturally, the more terms you use, the better of a window you'll get here, the better an interval you'll get. But just using four terms, it's still not bad. Okay, now 0.7 is all the way over here. Okay, so my actual sum has to be between these numbers. 0.7 is all the way out here. It'll never equal 0.7. All right. Let's do another one. All right, next example, they want me to know, or they want me to find out how many terms this time, how many terms I need to get an error less than 1/1000th. Okay, so remember, you know that your error is the next term. Okay, so I just need to figure out which term is like smaller than 1/1000th. All right, so what I set up here is an inequality. I just need to figure out which term, okay, so this is a sub n. I just need to solve for n. I need to figure out which term gives me a value less than 1/1000th because then that term will be my error term, if that makes sense. That'll be like the next term. All right, so absolute value bars, which means I'm really just looking to figure out where 1 over n to the fourth is less than 1 over 1000. Right, now the reason why we use absolute value is because the sign of error doesn't matter. It's always positive. Okay, so really here I'm looking for where 1000 is less than n to the fourth. I remember if you inverse both sides, you flip your inequality, which means that 5.623 is less than n, so n is 6. Okay, now again, I want the sixth term to be my error. Okay, that means like a sub 6 is my error term. So I need 5 terms. Okay, so I want to find like s sub 5 so that a sub 6, so using the first 5 terms and add them together, that means my next term, the 6th term, is my error, which is less than 1/1000th. All right, that's how this works. All right, that's it for this. I'll see y'all later.